In this video we'll be looking at the file inclusion section on DVWA. So as usual we're starting with the security level set to low, and let's take a look at the help section. And it says here, some web applications allow users to specify input that's used directly in file streams, or allows the user to upload files to the server. At a later time, the web application accesses the user input supplied in the web application context. By doing so, it's allowing potential for malicious file execution. So two possibilities here. We have a local file inclusion where the file chosen to be included is on the local machine, and then we have remote file inclusion where the file may be included from a remote machine, as the title indicates. And it also notes that whenever RFI is not an option, you might be able to use a local file inclusion vulnerability and upload a file. So if there's a, say there was a, we're going to look at the file upload vulnerability section next. Say there was a file vulnerability upload, a file upload vulnerability. We might be able to exploit that to actually upload a file to the local server and then use a local file inclusion vulnerability if we don't have a RFI one available to us. Okay, so let's check out a challenge. We need to read all 5 famous quotes from hackable flags fi.php using only file inclusion. And the low level says, this allows for direct input for one of many PHP functions that will include the context when executing. Depending on the web service configuration, will depend if RFI is a possibility. Okay, so just before we start the low difficulty, let's have a look. LFI, RFI. Okay, we'll grab a cheat sheet here. I'll leave a couple of links in the description to some sites to check out. Here's a cheat sheet we could begin with. I'm also gonna look for, see if we can get some more info on a file inclusion attack. And we have an article here on offensivesecurity.com which goes through these same DVWA challenges that we're going to be going through. So again, worth checking out. If you do check this out, you'll notice that whenever they get to the RFI section, they discuss the issue that's mentioned here in terms of if you want to do RFI, it'll depend on the web server configuration. So if you want to do RFI, it'll depend whether you enable the allow URL fopen and allow URL include whenever you set up DVWA. If not, you can follow this guide to do it, but if you followed along with me setting this up in the first video, then we did enable that stuff, so we should be able to do RFI. Cool, let's close that down. Let's take a look here at the cheat sheet. You can see here we have a general example of a directory traversal attack. So you might just have file include, there might be an image in the local directory that we want to include, but we might then, if we know that we're able to include a local file, then we can go and start fuzzing different directories and seeing if there's any interesting files that we can retrieve. You can see here some good commands here to check out. Let's go and check out the source code as well. Very simple source code. We have a PHP file, and the file is simply is equal to, and then get whatever page we're requesting, which we can see here the page is set to include PHP. So if we click on file1.php, you can see we have hello admin, your IP address is, and then let's check file 2. There we have file 2. And then file 3. Let's, out of interest, see if we can load any additional files. Okay, file 4, good job. This file isn't listed at all on DVWA. If you're reading this, you did something right. So as we discussed in our first episode of brute forcing, we could potentially go through, if we know that files are typically, whenever a file is uploaded, it's named as file with the index of the file. We could loop through and potentially try like from files 1 to 1000 and see which files exist. In this case, it doesn't look like we're going to get past file 4 anyway, but this is how we're including these local files. So these files are present in this directory on the website, and we're including them using the page parameter here. So let's go back to our help and see what we've been asked to do. we've been asked to read 5 famous quotes from /hackable flags fi.php. So let's change this to /hackable flags fi.php, and we don't actually have any output there, maybe due to the fact that this is the PHP file. We don't know what that PHP file is actually doing. Let's try and add some more. Okay. 1. Bond, James Bond. 2. My name is Sherlock Holmes. It is my business to know what the people don't know. A line is hidden. And then we have 4. The pool on the roof must have a leak. So it was just the directory. So that hackable directory isn't one directory down. It's actually 2 directories down. Let's yeah, you can see if we go 3 directories, we get nothing. So let's what we could potentially do would be to try to brute force. Now that we know that this directory has the fi.php here, we could try and brute force this URL for different PHP files. Bit of an off topic, but just to show how we could do that, we can use GoBuster. Let's check the GoBuster help. GoBuster. So I have a command GoBusters which I have set up for this, so which kind of automates some of that. In fact, let me check my aliases. So we have this GoBusters where it's running GoBuster directory as the mode, and then we pass in a word list, just a generic word list here, and then we pass in whatever URL. So if I run GoBusters, and then we pass in our URL, and then we can then also say, if we want to say like dash, oh, it doesn't actually have it there. You must need to check the manual to get the full list. But if we do -x, we can say what file extensions we also want to search for. So in this case, let's maybe say that we want to search for PHP files only. Okay, we get a wildcard there. That may be due to us not having the required cookie. Let's see our help. GoBuster. GoBuster -h. Okay, there we go. And we have our cookie string. So let's try that again, and let's do -c for cookies, and then security equals low, and let's grab our session ID. Oh, it's funny, we've still got that there from, let's take that out. PHP ses ID equals, paste that in. Okay, we get error code 200 now, but we're still getting the forced we're still getting, it still essentially brings back an error code 200 even if it's incorrect. So let's say here, you see there, we just put in a completely random extension and it still brings back a valid page. So what we could do there is we could use wfuzz. I know, again, a little bit off topic, but let's take a look at this. We could do wfuzz -c for colored output, and then we'll do -w for word lists, and we want to do the directory. Let me just do that. Okay. Bash aliases. I just want to see what word list we were using there, what directory list. Grab GoBuster. Let's grab that. use a shared dirbuster. Okay. So we've got a word list there, and then we can pass in our URL at the end. We also need our cookie as well. Let's do -b and say security equals low, and then our PHP ses ID equals, paste that in, and then finally our URL that we want to brute force. In this case, we're going to do this, and we're going to say fuzz.php. So we're just looking for PHP files on this directory. Should have everything plugged in there, I think. You see we get an error code 200 on every case. So what we'd want to do in this case would be say, well, let's we know that all these responses are just going to be the length of the response is going to be because it's got the empty page. So let's say we'll hide the lines, which is HL81. So let's do that again. Oh, --HL, my bad. I could have probably put that at the end. I'm used to having this at the beginning of the command for some reason. And you can see it's running through there, and because the response is always coming back as 81 as the length, it's not giving us anything. If we did happen to find, you see there it's found the fi.php on its own, and it found that because it was 92 lines instead of 81 lines. So we could keep running through that, and this would be another way to test for additional files in this directory that we might be able to include. So we'll leave that running in the background, why not, while we go back to this. And now that we've seen how to include a local file, let's see as well, before we change the difficulty, let's see if we can check out remote file inclusion. And in order to test this out, let's cancel this. I don't know if it's going to find any more files, but we'll find out another way whether there's more files there. Anyway, we'll see if we can actually get access to the server. So one thing we could do here, do we have any interesting files here? No. Let's see if we can locate a shell.php. PHP reverse shell. Let's have a look at this one. Or this one. Let's take a look. And we'll open that up. PHP reverse shell. Okay, loads of comments. Okay, this is a big one. Alright, that's fine. Let's just leave this. We can leave it at localhost because we're connecting from the localhost. This would be the IP that we want to connect back to, though. This is a long one. You can get a reverse shell, in a couple of lines. PHP reverse shell. But let's test this one out, see if it works. Close that down from the last challenge. Okay, and I'm going to also move that and just call it shell.php. And we're going to spawn a Python server. Let me minimize that, just so we can see the background a bit, or the terminal a bit clearer. So I have a command again to do this. Let me see what it is. If we do so web up, we'll do sudo python-m http server 80. That's for Python 3. If you're doing Python 2, it would be python 2-m simple http server, and then you specify the port. In that case, normally I do port 80. Let's say this time that we'll do port 9000. And you can see now we're serving HTTP on this port. So we've created a HTTP server in this directory now. If we go to our browser, let's go to our local host on port 9000, and you'll see here we have our files, and there's the shell.php, and we can copy a link to that. And essentially what we do here is you see here that the requests were actually made to the directory. Let's go back and set up a netcat listener and see if we can actually get a reverse shell. Do nc-nlvp 1337 we set the port to, and then now instead of requesting that file in a browser, instead of requesting a local file here and saying give us this local PHP file on your server, we might be able to say no, actually give us this PHP file on my server, and if it loads that and executes it, we might get a reverse shell. Let's take a look, and we did, yeah, straight away. So you can see here that the shell, it was retrieved, and we now have a shell here. We can say who am I, where am I. So we've got www data because that's who the DVWA is running as. And if this was a real server, if somebody had this vulnerability on their actual server, then we would now have full access. As admittedly as a low privilege user, our goal now would be to enumerate the system and try and escalate our privileges to a privileged user and ultimately to the root user. And that's the RFI and the LFI demos. Let's move on to the medium difficulty and see what changes. So difficulty on medium, we have a look at the help section here, medium level. Developers read up on some issues with LFI and RFI and decided to filter the input. However, the patterns that are used aren't enough. Let's check the source code then, and we have some string replace that's being used. So if we supply HTTP and HTTPS, it's going to be stripped altogether. If we supply ... or ... then that's going to be stripped as well. Okay, let's compare it with the first level we had. The first level did nothing, it just took whatever we gave it. So let's keep that open and see what else we can do here. Let's try and access our file 1. And now if we do ... the hackable, you can see we don't get our data this time. Let's go into Burp Suite. Another way to do this would be to send this to the repeater, and it might be a little bit easier. In some cases, you might have to play around using different syntaxes here. So you might use some, you might encode the dots and the slashes. You might use different syntax depending on the operating system, depending on filters that have been set up, or you might just need to keep adding more or less slashes and testing. And for doing that, then sometimes it can just be easier to use the burp repeater. In this case, it's not ideal because we have to keep scrolling down to see where the data is anyway. Although I'm no expert with burp. I'm sure there's probably an option to have it like highlight the same thing each time. If anybody knows how to do that, auto scroll to match when text changes. That sounds good. I would be interested actually to see whether that works now. I send that and then send ... Oh my god. I have insert enabled somehow, which is not something I pressed. Okay. It's a little harder for me to see it in here. Let's go back to our... Okay. Just keep playing around with the ... slashes here. What we might be able to do actually... okay, let's go back to what it should be. It should be ... If we add another ... and then a // there we go. Okay, so let's take a look at our code again there. View help, not help, view source. So you can see here that the string replace is replacing .. or .. So let me try and visualize this a bit better in a text editor. Grab our URL. So if we put in here .. the filter is going to remove .. so this gets removed. It's going to remove this. So it tries to access hackable, which isn't even, it doesn't even have the slash there to make it a directory, let alone 2 directories up. Whereas if we had here .. // what's going to happen here is it's going to remove this .. and then it's going to remove this .. and it's going to leave us with this .. So that was the issue with the regex there. Let's see about the RFI as well. So let's set up our web server again. Okay, I'm using port 80 for DVWA, so python-m http.server, and then we'll do port 9000, and then let's close that down again. Let's go back. Oh, let's set up a netcat listener as well, nc-nlvp1337. Let's go back here and try to access HTTP, and we still have our URL here, the shell one. Try to access it, we get nothing. If we go back to our terminal, you can see that we have nothing here either. So there was no request to our shell, and that's obviously because we have the source code here, which is stripping out our HTTP : // So there's a few ways we could solve this. Here's a very simple example. We could just say capital H and run that, and there we go, we've got a shell. So there was no it doesn't check the case of the HTTP here, so it doesn't check the encoding. So there's a variety of things you could potentially do here to make that work. You could also do something similar to what we did here with the .. as well, to make it strip out some information and then leave HTTP in its response. So for example, let me give an example of that actually. Let's close down our shell and let's get a new shell. Let's say we'll take this URL, paste that in there. We'll do it lowercase HTTP, and it's going to strip out this HTTP : // So let's try and do another HTTP : // Let's send that. Let's spawn our listener again. And you can see there that's got a shell. So it's looked in the string and it said, do you have HTTP : // It said, yep, you've got it right here, we're going to strip it. And then it just sends the rest off without checking to see, does this meet the requirements. And that's the RFI for the medium difficulty. Let's go and check out the, let's close down our shell and go and check out the high difficulty. So if we check the help section here, we can see that for the high level, the developer has had enough. They decided to only allow certain files to be used. However, as there are multiple files with the same base name, they use a wildcard to include them all. So let's have a look at the source code and see what they've changed. You see, instead of, they don't have any regex now, check in, but they have if the file name match, and we're seeing the file should begin with the word, the name of the file should begin with the word file, and then anything come after that, and either that or the file should be include.php. So if we're trying to retrieve what was the file we were trying to get? The // hackable flags fi.php. We get this error, file not found. So there's a couple of things we could do here. We can potentially use the file wrapper here. This is kind of similar if you open a file from, if you open a file in your browser, let's do Firefox. What files do I have here? Firefox readme.md. You can see here that we have this file and the //. So similarly, let's try that here. That didn't get us in there. Let's try this. Let's try with our etc password file, and then we actually brought back our etc password. So here we need the directory path, which I'm not too sure what the directory path is for that hackable. It's going to be okay. This would be the directory. So in order for us to do that, we could, if we knew where that was, or we were able to fuzz that, we could say file, and then in here it was flags fi.php. There we go. So we can retrieve it using that method. Another method we could potentially use is a null byte. So I'll link this in the description as well about null byte injection. And some suggestions that it uses here, it gives an example for PHP where a file extension might be added on to a file. So we might be trying to request etc password, but it adds .dat onto the end, and therefore it doesn't recognize the file. So the null byte can be used at the end of us submitting etc password, and then, or for example in this case, say the file has to end with JPEG or .dat or whatever, we can send that off. We can send the URL with the JPEG or .dat at the end, and use this null byte to make sure that that's not actually, it doesn't actually try to read the JPEG part of that. So let's see if we can do anything with that. So the file needs to begin with file. So if we were to just say file, and then let's do file, and let's try and do our .. after that. Begins, and then .. and let's use the null byte. File not found. Okay. What about if we do our var/ww /html/dvwa hackable flags? Okay. Let's go back. Yeah, okay, that doesn't seem to be working for me in this case. And for our remote file inclusion, let's go back to the code here. For remote file inclusion, we would need to use a separate file upload vulnerability. Remote RFI, I need to link in another vulnerability such as file upload. I'm not going to do that in this case because we've been through the RFI in a couple of examples. Essentially, that shell.php script that we've been uploading, we would just use another vulnerability like the file upload vulnerability, which we'll be covering on the next video. And then in order to execute the file, we would say, in this, for the high example, we would use this file // and then the location of shell.php, which we've uploaded onto the local server using our file upload vulnerability. So I think it's pretty self-explanatory. You know what's going to happen if I do that manually. So We'll not do that. Let's go and change the security level to impossible and just see what changes here. So file inclusion, we go to our view help and see what's been changed. Impossible level, the developer calls it, quits, and hard codes only the allowed pages with their exact file names. By doing this, it removes all avenues of attack. Let's check the source code. And you can see that the source code there says if the file is not equal to include PHP file 1, PHP file 2, or file 3, then don't display it. So it's only going to allow us to access these 3 files and then the include PHP file that it needs. If we try and change that now, let's say to file 4.php, we get file not found, even though we know that there was a file there. Okay, and I hope you've enjoyed this video. Any questions or comments, leave them down below, and we'll move on to the file upload vulnerability next.